Get them. We are missing one of those, one of those. Yeah, I'll just pick numbers at pseudo-random. No idea how it's going to work out. You might have to use a calculator to do some heavy lifting for you. Yes, those calculators are finally actually dying. A month and a half later. Pretty sure it's been almost 2 months since I've charged them. The top row should be good, though. No one ever uses those. Mm-hmm.
How do I get the fraction on here?
Alpha, y equals, brings up all the different types of fractions you can enter. Just hit enter on the first one. You got box over box.
Thank you.
Mm-hmm. We use those incessantly with Algebra 2 and pre-calc, but they're kind of overkill in here. You like pheasant hunting with landmines. And remember, as you do them, write out your steps, write out your process. Do we finally have? Nope. Who's still rolling? Nothing. All right. Stage one. To get to standard form, you need to start in either slope-intercept or point-slope form. Take your pick, but both of them need a slope. So I'll at least start there. Label x1, y1, x2, y2. It's that same song and dance that we've done about 100 times now. We're going to put in negative 15, 4, 6, negative 12. Get negative 19 over 18. Not a pretty slope at all. But that's okay. Doesn't matter if it's an ugly fraction. We're going to get rid of it. That's kind of the whole point here. So whether you know what, we'll do two-tone here. Depends which route you took. If you said y is mx plus b, or y minus y1 is m by x minus x1, whichever of those two you go into, you now know your slope. So I got negative 19/18. For both of them, you can choose either coordinate. Do y'all have a preference of which one? It really does not matter. Maybe do Negative 12.4 just because it's a little bit smaller. So the chances I might be able to do some mental math are higher. So I'll put in a 4 here and a negative 12 here. I'll put in a negative 12 here. No. 4 here. Negative 12 here. The reason I'm doing it two different ways is because you could have done it two different ways. Either one of those. Here, I'll reduce. Calling that, sorry, plus b. Running out of room to write. 4 is 38 thirds. Plus b, subtract. And get 12 thirds minus 38 thirds is negative 26 thirds. So y is negative 19/18 x minus 26 thirds. You're like, ew, I don't want to do this. Gross. All of your variable stuff to one side, not variable stuff to the other. And it looks like it's so disgusting because this whole way we had fractions. Let the calculator do the heavy lifting if you need to. The last stop on the train is to get rid of those fractions. If I multiply the whole honking thing by 18, get 19x plus 18y is 3 and 18 will cancel as 6. 6 times negative 26, negative 120, 36, negative 156. You have to check my mental mojo because 4 hours of sleep does not cut it these days. Over here, what I want to do is right away. We did this yesterday. I'll take the whole thing times 18 right now so I don't have to deal with fractions at all. I don't like fractions, so I'm not going to deal with it. Turn that into plus the opposite. That gets me 18y minus 40, 32, negative 72 is negative 19 by x plus 12. And now it's just big numbers instead of fraction numbers. Distribute. And minus, so what's that? 240, 12, 228? I hope you're checking me. Because I genuinely don't trust my mental mojo right now. Add 19 to the other side. Add 72 to the other side. Well, hot diddly dang. It works. Said, just pulled random numbers out. It's no different than if you had a word problem. Word problem might have big, ugly numbers. There's a tank with 31,256 gallons of something in it. They're just going to throw random numbers at you. You can still do the process. You let the calculator do all the heavy lifting. Or some guy who's slightly cross-eyed but can still do mental math. Did you get your correct slope? Did you plug the relevant information into either point slope or slope intercept? Then along the way, did you simplify it, get rid of the fraction, throw everything to one side? So slope, plug it in, get rid of fraction, do work, got to the end of the rainbow. Okay. Maybe Tutu back me up here. Just today, in pre-calc, literal equation, I threw that in front of them. They kind of freaked out, like, wait, you didn't say there would be too many letters. Because that concept that we did first semester in here, they used with logarithmic equations that took up the entire board in one shot. But it was the same concept. And I kept relating them back to stuff that we did in AlgHalf, saying, what would you do here? Okay, what should we do there? And they saw it was the exact same process. It was just uglier. This is the same process that we dealt with before. Just had fractions. Deal with fractions. So, A. There's two of you who still have stuff on the counter to pick up. Just get that out of the way. B. Oh, homework questions. I don't even know if there are any because no one's asking. Oh, hey, we got questions. Yay. Okay. Talk to me, Goose. Okay. So it's either words or fractions. Ah, words. Okay. Video game, 5 points for every jewel you find, 2 points for each star you find. I've seen such a resurgence in Clash of Clans among the student population. It's like Clash Royale, and then they find Clash Clans. Go find, the classics become popular again. Well, there you go. Elixir, Dark Elixir. Okay? They're worth different things. 5 points for this, 2 points for that. They're worth different things. Those sound an awful lot like rates. And that's what we did before. Remember, rate X plus rate Y is total. We wrote that little word problem cheater down because they say blah, 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 to earn 250 points. So if I have rate X plus rate Y is total, I know rate number one. Well, first of all, before I do anything, I should label what I'm talking about. If I'm going to have X and Y in here, and this was your last quiz, you can't just say X and Y. You have to define what they are. Or worse yet, in the problem, they told you what variables to use, and you decided to use X and Y instead. Okay? If I'm going to use X and Y, then I'm going to call that joules and stars. That way I know what they are. Then I know that the rate that goes with every one of the joules and the rate that goes with every one of the stars are going to be attached to X and Y respectively. And my total, 250. Okay. Once you have that, go find your X and Y intercepts. Gonna make just a ugly sketch of it here. If I jam a 0 in for X and divide, I'll get a Y-intercept at 125. If I jam a 0 in for Y and divide, I get an X-intercept at 50. Make my scale accordingly. If I got to go all the way up to 125, maybe I just go by 25s. Probably don't want to go by 5s. That's a boatload of boxes. If I have to go out to 50, maybe I go by 10s. Okay, make the scale work for you, and then connect the dots. Okay, we got this pattern. Step 1, label what you're even talking about. Step 2, use one of our cheater forms. Y equals rate X plus start. Y minus output equals rate times X minus input. Or Rate x plus rate y equals total. This is a problem that gave us a total. So put a total in there. 3, you plug in what you know. 4, go find your x-intercept and y-intercept to do that quick graph from last time. 5, make your graph using your appropriate scale. Those steps. Y'all, you get to tell yourself how to do a test. Write steps. Then it's not even thinking, it's just following instructions. Okay? I am not a good cook. I can follow a recipe. I could never do it myself. I could never just come up with something. But I can follow instructions. Write the steps. Label your variables. Choose which format it is. Plug numbers in. Get your x and y intercepts. Get a reasonable scale. Connect the dots. 5 steps. That's how you do these word problems. Okay? And I think I only had the one on the assignment. Pretty sure. Utters.
56.
6. Next page. Fractions are words. Oh. Just like our daily quiz. Hey, step 1. If they're giving you 2 points, then you don't have a slope. And every time we start, we need a slope. So I'm going to start by y2 minus y1 over x2 minus x1. That's the very first thing I'll do. Get myself a slope. y2, 13. y1, negative 8. x2, negative 4. x1, 3. You did say 56, right?
Yeah.
Okay. So add the opposite, I get 21. Subtract, I get negative 7. Reduce, I got a slope of negative 3. And then you get your choice. You're the one who asked. Do you like point slope or slope intercept better? Which one makes more sense?
Point slope.
Okay. I like that one too because they have a point, they have a slope. So that's step 2. Y minus y1 is m by x minus x1. I'll say y minus, okay, which of those 2 coordinates do you want to use?
Negative 4 and 3.
Okay. Or 13, right? So y minus y1 is 13. M, negative 3. X minus, careful, negative 4. So I add the opposite. That's another thing. Make sure you're simplifying that when you're writing equations. There's a couple of you who got docked that one because you didn't actually simplify your equation. Call that y minus 13 is negative 3 by x plus 4. Step 3, I'm going to rearrange it until it looks like ax plus by equals c. I'll disturb it. X stuff to one side. I'll add 3x over. It's not like terms with anything, so it just stays there. Not x stuff to the other side. I'm going to add 13 over. I'm in standard form. I even got integer coefficients. Wasn't required of me, but it was nice. Once I'm there, they didn't ask for the equation. They asked me to find my intercepts. Intercepts is that plug a 0 in, cover up x and y business. If I plug a 0 in for x, I get my y-intercept is just 1. If I plug a 0 in for y, be careful which way you're dividing. You want x by itself. Divide by 3, divide by 3. My x-intercept is 1/3. So this is one of those that would have a x and y intercept that are really close to the origin in the middle. And it would be very hard to make a line out of just those 2 points. Again, it's like a snub-nosed revolver. Very hard to aim. So you'd have the choice of either using that slope. I would go up 1, right a third, up 1, right a third. Y's over x's. I would keep doing that to make more points. Or maybe I would turn it into slope-intercept form. And you get the choice. That's why we're giving you all these tools, is these tools are going to be used for the next 3.5 years. Longer, if you're heading into college and you're not going to enter college at a, Calc 1 or better level. Because the very first thing you have to do in college, you go to a tech school. You go to Western Dakota Tech because you want an associate's in construction technology. College algebra. It's called a general requirement. If you want an associate's, at a bare minimum, you need to do college algebra, college stats. College algebra is basically algebra 2 again. Okay? You're going to be using this for years. We're giving you the tools so that you can choose which tool is right for the job. Now, I know most of you have probably banged a nail into something with the back end of a screwdriver, and you weren't supposed to, but it was all you had on hand. Someone in here has probably unscrewed a Phillips with a flathead because it fit and, well, it's what I had. But isn't it a lot easier if you got the right tool? Okay. Even those little, it's not even a drill, it's just like a electric screwdriver. It's got the little wimpy motor in there. It's literally just like a really thick screwdriver and just screws it for you. The right tool for the right job. Killian liked point slope, she used point slope. Maybe your jam is slope intercept instead. We're halfway through. It's time for a reminder. A, do your work. In no particular order. Homework and note completion in this class. 39%, 25%, 18%, 48%, 58%, 22%, 60%, 51%. 11 of 19 students have a third or more of their coursework not even attempted. Blank pages. That's why it looks like that. A class 5 years or 5 classes past where you're at right now, they just show up and do the work. That's it. There's only like 4 kids out of 48 that actually come and ask questions on a regular basis. All they're doing is just showing up and doing the work, and I run it the same way. You have to pick up the pencil. Okay, we're on the back half now, where the next 21 class periods, that's your grade. That determines whether you take this class over again or not. Okay? Taking a nap during class is not going to improve that situation. In terms of the grades, I went through it all on day one, and there's a good chunk of you who apparently weren't listening. Turning in 1 or 2 assignments at the buzzer, especially if they're already in my grade book, isn't going to move the needle. I got the percentages. Where'd it go? Percentages are right there. The entirety of your grade for the semester. I don't average quarters. That's archaic. That's like 70s era. %10 blocks. This is the entirety of your grade for the whole class. Think of it like your health, your armor level. Homework and notes. That's it. I give you 10% of the grade just for doing what you're supposed to. The daily quizzes that some of you insist on still falsifying. It doesn't matter if you're all 4s and 5s out of 5. What does that tell your parents when I say the daily quizzes are self-scored and they're getting 90% plus on them, but they're getting C's and D's on their tests? That tells everyone we're not being truthful. Your final is only 10%. Your tests are everything in between. We're going to take about 6 of them for the semester total. So that means each one is worth about 12% of your grade overall by the time the end of the year hits. We're halfway there right now. You don't like what you have? Step up. You got to do something. Okay? Several of you have advocated for yourselves, have little, some accommodations, maybe alternate assessment. I've got one who's got a different set of assignments. I've got one that I do video assignments with. We check in every couple of days and we do a Discord chat. That's their homework. Okay? I'll do what works for you if you're willing to talk and willing to pick up the pencil. Oh. Are we willing to pick up the pencil? 5, 6, here we go. We're halfway through. So at this point, either you're doing it or you're not. I'm just going to stop hopping up on that soapbox and just say, look, you make choices. Okay? Make choices. You know what you need to do. 5, 6 is do all of the exact same stuff that we've been doing for the last 3 lessons. One catch. I'm going to add in 2 vocabulary terms. And that's it. They're vocabulary terms you should have heard before. Y'all remember hearing parallel lines. Okay? Maybe remember it from the geometric concepts you saw in middle school. Maybe it was algebraic, I'm not sure. Parallel lines, think train tracks. They're never going to cross. Think of what happens to a train if those are not perfectly distanced apart and one of them bends in a little bit. Right? You get Amtrak on the evening news. Splat. We don't want that. What do you think about these two? Like, what's an observation you could make of them? They both have the same slope of up 1, right 2. It's right there next to it. To be parallel lines, they have the same slope. give you a little taste ahead, or maybe you've seen this symbol or not. Things that are parallel, I would say they would label the lines like L and K, and they'd say L is parallel to K, like this. Parallel is a symbol that's basically the train tracks. Okay, they're kind of squished together. You want to get them real squished in together so it doesn't just look like an 11. Maybe make it a little bit taller so you know they're not numbers. But L is parallel to K means the slope in L is up 1 over 2. The slope in K is going to also be up 1 over 2. They're going to be the same. So when they tell you to make parallel lines, the only thing that you care about is the slope. And they say, we're going to go through this point, and it's parallel to that line. That -1 is useless to you. Means nothing. The only thing you care about is the slope. Because if this has a slope of 2/3, parallel to 2/3 is another 2/3. So that tells me that's the slope I'm going to use. So I've got a point, I've got a slope. What do you want to do with them? Point slope form or slope intercept form? You get your choice. It didn't even tell you how to do it. It just told you end up in slope intercept when you're done. Okay. Maybe you like doing this old school. Y equals mx plus b. I know a y. I now know my m. I now know my x. Go find b. What's 2/3 of 12?
8.
1/3 of 8 is 12. So 2 of them is, yes, 8. 2 of them. Okay, so I've got 8 plus b. Finish it off. Subtract and find b by itself. Now, I am personally a fan of point slope form. I told you this in class, or at least on the video when we had to go through it, that some of you still haven't watched, because the number of watched views on the video is still less than our class number. Some of you did this on the tests. You'd get there and then just quit. Do I have my equation in slope-intercept form? Okay. You need to finish it off, and that's why I personally don't like this form. I'll still do it that way if you want me to, but I now know my b, I now know my m. I need to write the equation. And there were several of us that did that on our last test. As we went and found the slope, great. You found your y-intercept, awesome. What's the answer? And just kind of left it hanging like that. Alternatively, and this is why I prefer point slope form, y minus y1 is m x minus x1. If I start in point slope form, I don't have to remember at the end of the problem to put pieces together. Everything's already there. I just have to flip this, twist that, turn it into Optimus Prime. Okay? I've just got to rearrange it. I'll distribute. We said that was 8. Add 5 to the other side. Add 5, add 5. Look how much faster that is. Not only is it faster, but I didn't have to remember at the end of it to put the pieces together. It was already there. That's why most modern textbooks, as you go forward through your high school career, they're probably going to start every one of these problems in point slope form. Because it's just faster and everything's in one place. So, there you go. You want to go through those 2 points, it's got to be parallel to that. Remember, what's the only thing in there that you care about? Use that thing. It has to be parallel to that. I don't care whether you use slope intercept or point slope to start. Just make sure you end up at slope intercept by the time you're done. What is this? If you just start with point slope form, since you're going to have a point and a slope, everything's in one spot. I know my point. -1, -3 as my y and x. What's my slope? The only thing you care about over here is the slope. This is useless to you. You want it to have the same slope. The rest of that is useless, so don't use it. Just shove that 2 right here. Then, add the opposite, distribute, that's 2x plus 6, subtract 1. Done. These do not take a lot of work, but you got to know what you're doing. Okay? The antithesis of parallel lines never going to cross paths is, what if it's just straight up T-bone at the intersection? You ever seen that happen? Jackson and Maine? Got that one putz who wants to run the light. Well, there you go. Do you remember these? Did you see these before? I don't know what you did with middle school. Okay, these are perpendicular lines, and they're very special in that they're going to put that symbol in the corner. Remember what it means? I got a right angle. They meet at a 90-degree right angle. So when I say that line L and line K are perpendicular, the symbol for it is kind of an upside down capital T. It looks like it hits at a 90-degree angle. Okay? Now, instead of having perpendicular slopes, instead of having the same slope to be parallel, to be perpendicular, well, what's the slope of the blue guy? Up how many over however many? Up 1 over 2. Okay? So I have 1/2 is the first guy, and that's going to be perpendicular to, what about the orange guy? Down to right 1. If I leave that as a fraction, what do you notice about perpendicular slopes? They're flipped. Do you remember the big kid word for that? Starts with an R. There we go, reciprocal. Okay, a reciprocal is I flipped the fraction. But it wasn't just flipped. It was a reciprocal that was also negated. So that's what you're going to write. That perpendicular slopes are negative reciprocals. So if one of them has a slope of 3, what's 3 as a fraction? 3 over 1. Flip it, change the sign. If my original was negative 1/5, flip it, change the sign. Positive or negative. Okay? Regular old 5. If I had 2/5, that's perpendicular to negative 5/2. Flip it, change a sign. That's what perpendicular is. And that means that when these two lines run into each other, they're going to land at a perfect 90 degrees. When you're graphing these, that's how you know you're right. You should be able to take the corner of your notebook, of your ID. You should be able to put it right in that corner. Okay, like probably even do it right here. I should be able to jam this in the corner and it fit perfectly. That's how you know they're perpendicular, is they're going to land on that perfect 90 degrees. Okay, so these ones, they don't even want you to graph anything. They don't want you to do much of anything other than just tell me what kind it is. And I say, are they parallel, perpendicular, or neither? No ding. Okay, it's tripping us up because they're not in the same form. I don't know what the slope of this one is until I rearrange it. And we're trying to do a little bit of mental math and then compare. So how about you do exactly that? Get this one in the right form. Divide everything by 4. Getting y is negative 5/4, x plus 3, and for fifths x minus 8. Again, I don't care about these. The y-intercepts mean nothing to me when I'm answering this question. I want to specifically compare negative 5/4 and 4/5. They flipped it, and they changed the sign. Parallel, perpendicular, or neither. Perpendicular. So you can either write out the word perpendicular, or you can get used to that symbol. Mathematicians are notoriously, shall we say, conservationists of our ink. We like using symbols instead of words. Okay. What if it ended up negative 5/4, negative 4/5? Neither, right? Because they flipped it, but they didn't change the sign. So they're not the same, so it's not parallel. They're not negative reciprocals. So I would just say neither. Okay. Y'all make that note to yourself. Tell yourself, get it in slope-intercept or point-slope form. Ignore everything but the slope to answer this question. Just compare the slopes. Get them? I can't compare them until I see what the slope is. If you want a little bit of work on there to prove whatever you said, then maybe just put this thing, parallel, perpendicular, neither, that thing. Come on now. I gotta censor myself at school. Oh, I heard more than that, but that's... Stay on the bench. Stay on the bench. Get me some water. Yeah. Here, let me get a... There we go. What's up, bud?
I'm doing this right.
You can start by that, yeah. But we're not there yet. This gets you 4/3 x minus y is 9/3 is 3. Do you have y equals mx plus b yet?
No.
So I can either subtract this over and then divide by a -1, or it might actually be easier to add the y, subtract the 3, right? Because then I have subtract the 3 over. Now it's just pass backwards, but you can still see it, right? Now you got your slope.
Thank you.
Can you do 4 instead of 3? Does it still work the same?
That would be isolating x. Remember, I want the number that's in front of x because that's my slope.
Okay.
Easiest one is to put it in slope-intercept form, get y by itself. That's kind of what gets drilled into our brains in algebra half. Y equals mx plus b. Make it look like that. Our kids come in and do ACT review, and they haven't done Algebra 1 in 2-3 years. y equals mx plus b. Boy, do they got that pounded into their head. Does he do this at home too? Yeah. Covered half my board yesterday. Got skills. And Game Club's got a lot of pretty talented artists. I got one of the slopes. I don't have the other. Womp womp. You better stretch those legs, Inspector Gadget. Okay, I'm tempted to just let this keep going, but I'll subtract 4x. Negative 3y is negative 4x plus 9. Divide everything by negative 3. Negative over negative is positive. Okay. Now that's just one way I did it. Working with Dominic here, asked, can I just divide by the 3 right now? Oh, yeah. That's within math law. But now I have 4/3 x minus y is 3. It still doesn't look right. So what we had done was actually add y to that side, subtract 3 from this side, getting my slope-intercept version backwards. Isn't it still mx plus b? You just had your left shoe on the right foot. My kid had that the other day when I picked him up from preschool. I don't know why. He was just so crabby this afternoon. Look at his feet. Anyway, 3/4 and 4/3. You compare them. Are they the same? Are they negative reciprocals? So, neither. Do you say neither or neither? I kind of use both, and I'm not really sure why. Just like in the same problem, I'll do different 2's. This one, I do see negative 1/6. I don't have y by itself yet, so we'll divide everything by 6. That's 1. Do we remember how this works as a fraction if I have negative x over 6? What number is in front of that x? Okay, so it's a negative 1. X over 6 is the same as negative 1/6 x. And I see the slopes are the same, so I'll say they are parallel. Okay. Another way to remember that that's a symbol for a parallel. It's literally the double L's in the middle of it. So. Okay, so they're going to flip the script on us now and say, find the equation of a line that's perpendicular to a thing. So you do it the same way. I'm still going to say y is y minus y1 is m x minus x1. I've already got my point. I've just got to get my slope. So I look at the slope. I don't care about this. and I say what is perpendicular to 1/3. Flip, negate, right? -3. So -3 is my slope. Then rearrange it. I'll distribute. Y minus 4 is -3x plus 6. I'll add 4 to the other side. 6 plus 4 is 10. Okay? Look at how fast that is when we start in point slope form. But the catch is, I will see kids use this year after year after year. Instead of this, they'll find their perpendicular slope, they'll look at the point they're supposed to use, and then they'll do this. Well, it's the y-intercept. That's the y part of the coordinate. I can just use that, right? No, it doesn't work that way. Okay. Someone says, yeah, I have my charger. Here you go. And it's for the complete opposite type of phone that you need. Okay. Don't use that just because it's convenient. Make sure it's the right thing to do. Go again. Okay, set up point slope form or slope intercept if that's your jam. What's your x? What's your y? What will the m be? And plug them in. That is the tiniest negative. Okay. Oh, isn't it cute? I've got my x, I've got my y. So I just take this one off to the side and say 2 is perpendicular to what? Flip it, negate it. -1/2. Then I need to clean it up. We'll distribute. Negative times negative is positive. 1/2 times 1 is just 1/2. Add 8 to both sides. Please don't write 8 1/2. Okay? The compound fractions are, or not compound fractions, mixed numbers are kind of outdated. We don't really use them, but I could turn this into times 2 times 2, 16 halves. 16 halves plus 1/2 is 17 halves. Because it's a terminating decimal, if you had said negative 1/2 x plus 8.5, I would take it. I'm not going to be happy about it. I'm probably going to give you a little frowny face of doom next to that problem, but I won't mark it off because you're not wrong. Okay? We seem to have, our issue was the rearranging. I think we're actually okay just looking around. We're okay with plug it into point slope form and find it. I want to practice those. They gave you 3 different lines. I know it looks kind of gross because they just put commas in between them, but here's a line, here's a line, here's a line. Here's a line, here's a line, here's a line. Rearrange all of them so you can find their slopes, and then tell me which ones are parallel and perpendicular. So we'll just call this line A, line B, line C. We'll call this line H, line J, line K. Rearrange them, find their slopes, tell me which ones are parallel and perpendicular. Now. Here. Okay. Easiest way is if there's not enough room, do it on a separate sheet. But turn all of them into y equals mx plus b. Maybe with less stuff on there. I want line A in slope intercept form. Who's got to move? Subtract the 2x, yep. Getting y equals negative 2x minus 7. I want line B in slope intercept form. Who's got to move? Everything? I like that. Add 2y. Add 4. And when I divide everything by 2, I'll flop it back over. 1/2 x plus 2. I like that same thing here. Do add y minus 5. Because this part cancels out, this part cancels out. I now have y by itself, and on the other side I'll have 4x minus 5. So, out of all of those, are any of them parallel? Same slopes? Nope. Any of them perpendicular, negative reciprocals? A and B. So I would say A is perpendicular to B. And C, well, that's the odd man out. That's the goober of the group, the one that laughs 3 minutes after the joke. Okay, these ones, this is already set to go. This one, I'd maybe subtract 6x. And divide by negative 2. Getting y is a positive 3x minus 7 halves. This one, all I got to do is divide by 3. They're all parallel. They're all the same. And I can write that as a single statement by saying H is parallel to J is parallel to K. They're all parallel. They're all the same slope. Instead of writing, 2, 3 different ones, 3 different ones. So you see this algebraic manipulation, this idea of just moving things around, is pretty well embedded in what we're doing. The real world problems for these, they're more geometric than anything. When y'all go on to geometry, maybe second semester next year, I know some of you are doubling up, going Algebra 1 for every day for a semester into geometry every day for a semester. Some of you are doing that. Or do Algebra 1 every day or every other day like this. Next year, Geometry Algebra 2 your senior year, or maybe just geometry. Whatever your jam is, if you want to graduate, you need Algebra 1 and one other math credit. We recommend that it's geometry. When you head into geometry, some of the first stuff that you do is called geometric proof. Algebraic proof, coordinate proof, where you get some word problem context like this and they say, this is just a physical representation of the world. A couple of times in here I've told you, I need that back table, I need you to move 6 inches forward. Something like that. Why would I say that? Because I know that these tiles are all exactly 12 inches. Last year, I got a bunch of these tables out of here, and I had the physical spacing down. Every single student's center of mass, as they were separated around the room, were 5 foot 6 inches apart. Because I can do the geometry of it using all of these equations. Software design. Any of you, do freshmen get to do the CAD program? In which year classes? I know there's drafting. Okay, you do get to use this? Okay, so they've got some really slick programs out there, and it's all based on math. If you don't know the math, you don't know how to run half the program. They're going to enter an equation that represents a new beam across the ceiling of the room. Maybe the ceiling's collapsing, I don't know. It'll be perpendicular to the existing beam. That's the blue line. Inverted colors. The new beam will pass through the corner represented by the blue point. What is an equation representing the new beam? Well, yeah, it was just a really fancy version of, y'all, I'm going to make a point that goes through here. It's got to be perpendicular. I know the coordinate is at 12, 10, and the slope of this guy, even if these boxes are a little fuzzy, maybe on your paper, the copier didn't make them show up at all, can't you still go down 8 over 12? That's the information I need. Get rid of everything else. I just found out that I've got a slope of negative 8 over 12, or negative 2/3 when I reduce, and the point 12, 10, and I want to be perpendicular. What's my slope I'm using? Perpendicular. Flip it and negate it. 3 over 2. So I say y minus y1 is mx minus x1. Jam in y, x, and then I know negative 2/3 is perpendicular to 3/2. Disturber? What's half of 12? Times 3. 18. That's how you get 3/2. You do it in pieces. Or do 3 times 12 is 16. What's half of that? 18. Okay. That way you don't have to pick up a calculator. Add 10 to both sides. And get 3/2 x minus 8. So the application problems of this are more, let's use math to describe a situation. And honestly, that's all math is. It's a language. Math is a language with a grammar structure to describe physical spaces and abstract ideas. That's why Pythagoras had a whole cult about it. He thought you could become immortal if you knew enough math. Literally, the axioms of Pythagoras' cult are right up there above Grace's head. All was number, meaning the entire physical world can be described by numbers, right? I can measure stuff. Number was the substance of all things. Every single thing in the world can be measured and described with numbers. Number rules the universe. Well, if everything can be broken down in numbers, then everything in the universe is just a bunch of numbers. Number is the ruler of forms and ideas, the cause of gods and demons. Meaning, everything is described by numbers, including the abstract. Geometry is knowledge of the eternally existent. You've all heard Pythagorean theorem. Legitimately, Pythagoras had a cult that believed if you learned enough math, you became a god and you were immortal. He was a nut job. But then, I mean, Pythagoras, Greek, right? Like they actually believed that if I shake my fist at the sky, Zeus is going to nuke me with a lightning bolt. So, Greeks. They say a second beam, and we're going to go through 0, 10. Ooh, I like that. Parallel to the existing beam. Okay. So it's still the same picture, but they said we need another beam in there through 0, 10, parallel to the existing beam. Blah, 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 do what you just did. Okay? Remember, we just found out that one beam, we know its slope already. It's negative 2/3. How are you going to use that? Use them.
So, the slope, would I use this one, right?
This one.
Why is that?
Because that's the slope.
Oh.
Remember, we did perpendicular because we were going to make a beam right here.
Oh. Okay.
They said to the existing beam.
How do I get there? From this to there.
A over B is perpendicular to negative B over A.
Wow.
Flop them, change the sign.
And I find this. I'm sorry.
That one was by just counting our boxes. We went down 8, right 12.
Okay. Thank you.
Yo, this one's almost a... This one's almost a trick question because it's so quick and easy. If I'm parallel, what do I do with the slope? Same. What is that? It's the y-intercept. 0, comma, number is a y-intercept. Done. Specifically because it was 0, comma, 10. If it was 110, I can't do that. But because it was 0, 10 and it was already the y-intercept, I get to just use it. Okay? What is the next round? Scatter plots and trend lines. Y'all, bone up on your skills because the next one is more of the do a bunch of scatter plots, get an appropriate scale, make a reasonable line, make the equation of the line. Okay? No, that'll be our one variable stats. It usually comes at the end of Algebra 1. But if we have a couple of days at the end of the semester, then I might throw one variable stats in there. One variable stats are fun because you get to find out who in the class is actually abnormal. So. Oh yeah, we do standard deviation and find out everyone always picks on the one kid because they're short, and turns out no, they're actually just low average.